Hello, Martin Warwick here. We are at the Small Cells World Summit 2014 at Excel Exhibition Centre in London's Docklands, and I'm talking with Todd Mersch, who is the General Manager, Software and Solutions with Radisys Corporation. So, what factors are driving mobile network demand for small cells?
What we've seen with small cells today, and more specifically in LTE small cells, has been sort of a measured move from coverage to capacity. So a small cell provides significantly increases in capacity, better performance and experience for the end users. So you start to augment the network and service that demand for the data services. And then lastly, I think as we move forward, you'll see an opportunity to deliver better services over that. So whether that's services within the home or services in the enterprise based on an understanding of location, presence of the users in that environment, you can envisage the operators as well as even other application developers providing a myriad of services to take advantage of the small cell network itself.
What do you think are the key challenges, the problems that are being faced by telcos as they begin to deploy and implement small cell solutions?
What makes it challenging is things like site acquisition. Being able to determine where and when you can install these devices. If you want to put them inside a coffee shop, who really owns that site? Who do you have to talk to get the rights to put them in that location? And then the other side of that too is, from a training and operational perspective, how do you do that in a consistent way? So from one municipality to the next, the folks you need to work with, the cost of actually acquiring those sites may be different. So we've seen a lot of cautious movement driven by that aspect of things, and that changes from one environment to the other. So it may be a little bit more regulated in certain parts of the world than in other parts of the world where people may be able to move a little faster. But it's those sorts of things that seem to have been a bigger challenge than the technology.
Do you think small cell technology is actually capable of delivering telco requirements now, as of this moment, or does the technology need more development?
It's capable of delivering it now. That's why there are deployments going on. I think we're part of the Small Cell Forum, and more recently we were able to point to the fact that there's more small cells deployed in the network than there are macro cells. So it absolutely is meeting the telecom requirements today. But there's always further opportunity for optimization, and I think as you scale the number of these products that are being deployed, that's where some of the challenges and opportunities reside for the entire ecosystem, is to solve some of those challenges and then allow operators to go even at a larger scale than they are today, and maybe in a little less cautious way.
And how does small cells for 4G and beyond fit in with the move towards NFV, Network Functions Virtualization?
And there's two aspects to that. There's software-defined networking, which is being able to kind of control the way the network orients itself based on changing demands from a more centralized location. And I've seen actually more of that come into small cells in the early days. So being able to manage the backhaul demands through a software-defined networking approach versus sort of a static routing concept. And then more into, when you get to virtualization and cloud-based services, it's really come into centralized baseband processing, or what someone would call a cloud RAN architecture. Not a lot of folks in the small cell industry have a very strong linkage to NFV in its more defined term from coming out of the standards and things like that. It's one of the areas where we're a bit unique because our business does span things like small cells as well as the entire core network and the media processing side of things, where we're already having to virtualize our media server technology and provide solutions that enable this transition to SDNNFE on more of the infrastructure side. And then we're searching and working with our customers to map that into the small cells themselves.
What role do you see for small cells beyond 4G and into future 5G networks?
The thing for me is that there's a very practical way some of these things actually get rolled out. And in a lot of ways, the small cells are tracking against the progression of the radio interface. So when we talk 4G to 5G, you're talking about changes in the way the radio interface interacts with the handsets. And it's different types of modulation schemes and optimization schemes associated with that. And then slight changes to the architecture. So as you get to LTE Advanced, there's the concept of a relay node that allows you to provide better performance at the edge of the cells. And that's a new piece of equipment. So we think that, what I think at the lowest level is that as 5G air interfaces come to fruition, you're going to want to roll those out in the same way you're rolling out 4G air interfaces that have a mixture of large cells and small cells to just naturally augment that innovation. And one of the things we're challenged with as an industry is that as you go off and you do the next iteration of improvements on the air interface, you're starting to hit what's called Shannon's limit, right? And so if you were to graph the changes we got from going from our first data network to 3G to now LTE and LTE Advanced, you're hitting a curve, basically. So 5G is going to help take another leap, but a lot of what we're seeing in things like 5G is not just air interface, but topology changes, and that's where small cells will continue to play a role.
Todd Mersch, thank you very much indeed.
Thank you very much.